Hiya Nines, it's Miss McGinley here. So today in this video we're going to be looking at a group called Alkali Metals. So this is group 1 on the periodic table. So remembering that our periodic table is arranged into groups. So we have group 1, group 2, group 3, 4, 5, 6, 7 and group 0. But don't worry, we're going to cover those in other lessons. In the middle is a different group of metals called transition metals. Again, you'll learn about them another time. Today we're just learning about the elements in group 1. The reason they're called alkali metals is because they're all metals, and you may remember from year 7 that we can categorise things into being acidic, alkali or neutral, and all of these happen to be alkali. So we have 3 alkali metals with us today, and we're going to be looking at their reactivity with water. So I'm just going to turn the lights off so you can see the reactions a bit better. Okay, I hope you can still see that clearly. Let me just check. Perfect. So first things first, I need to put my safety goggles on. So I have here my 3 elements. Now, I don't know if you can see from there, but there is a corrosive warning symbol on the bottle, so I need to be really careful when using these. So corrosive means that it can burn through materials. Obviously these are mildly corrosive, they wouldn't burn a hole in my skin if I got a tiny bit on me, but it would irritate my skin. So what we have here is a trough of water, so this is called a trough. Different to something like a trough that an animal drinks out of, but same principle, like a dish with water in. Just filled with normal water from the tap. Now what I'm going to do first is put some universal indicator in here. So I want you all to think now, what colour would universal indicator go in water? It's a bit of a revision back to Key Stage 3. So we can see it's going a nice green colour. Just mix that around a bit. So hopefully this is what you thought as water is neutral. It's a bit green. And green indicates a pH of 7 using universal indicator, meaning that is neutral. Okay, we're going to first start by adding lithium to water. So you can see I've got a massive forceps here. I'm going to take a piece of lithium. I would often cut it down to size, but I don't actually think I need to with this one. It's already a good size. I'm going to blot it with oil. Sorry, with paper towel to get rid of the oil in it. So they're stored in oil because these elements, these group 1 elements, are very reactive with water, so much so that they can even react with moisture in the air. So, but then if we keep the oil on it, then it's going to prevent it from reacting with the water. So let's see what happens. Let me add lithium to the water. So hopefully we can see a little bit of fizzing, a little bit of moving around. There's some vapours being produced. Nothing too crazy, but there's definitely something happening. There are definite signs of a reaction there. Now, what I'm also going to do is add a little bit of universal indicator, because in theory, because we've added an alkali metal that's reacted with the water, our water should now in fact contain an alkali compound, lithium hydroxide. So we can see that the water is now an inky purple. Some parts of it's still green. There's definitely been another product made there. Okay, so lithium is at the top of our periodic table, the very top of group 1. So we're now going to go to the element below lithium, which is sodium. And what we're trying to find out basically is the pattern of reactivity. So pattern's like a trend. So we're trying to find out, do the elements in group 1 get more or less reactive as you move down the group? So on to sodium. Remembering sodium is a bit of an unusual one because its symbol is Na. So it might be quite hard to remember that symbol. So blotting the oil, add the sodium and stand back. I don't think I blotted it very well. There we go, now it's taking off. So definitely a bit more movement, more vapours produced. Moving around a bit more, slightly more vigorous reaction. So I'll stay well away from it until it's done reacting. It's good safety protocol. So I've got the windows open just because there's some vapours being released. Quite a big piece, it's only got a while to finish reacting. It's still going, you can hear the fizzing. Okay, finally done. And finally, last but not least, we have potassium. Potassium is another one where its symbol is K. Got quite a big piece here. So I'm going to make sure I step well back, because if we think about the two alkali metals we've just looked at, sodium was slightly more reactive than lithium. So if we think about following a pattern, it could be that potassium is yet more reactive than the two of them. So definitely a much more vigorous reaction there. Flashes of purple, flashes of orange, lots more vigorous movement and popping. Wonderful. So now we can see that reactivity in group 1 increases as we go down the group. Now, as you know, there are more group 1 elements. So if we continue, we have rubidium, cesium, francium. However, we're not actually allowed to use them in school. Cesium is an element that is used in fireworks, that's how explosive it is, but I will find some videos of rubidium and cesium to put on the Google Classroom. Francium, there are no videos existing of it exploding, as it is so reactive. Okay, any questions? Obviously just send an email or comment on the Google Classroom to myself or Miss Tomlinson. So hopefully you'll get to see this demo in real life when we're back in school.